Mhm. Good afternoon, good morning, or good evening, depending on when you're joining us from around the world. Welcome to the third session of our Emerging Nuclear Technologies webinar series, proudly hosted by Winnie and Win for Peace. Thank you for joining us. And today's topic is revolutionizing nuclear innovation, robotics, and emerging technology. Um, so before we start, let me just explain and just share a little bit of background of what Winnie does. The Winnie Group was launched in September 2021 under the framework of the partnership between Win Global and World Nuclear Association, being Sama Bilbao y Leon, the godmother of Winnie's initiative. Winnie aims to promote and strengthen the involvement of women in innovation and in enhancing the attractiveness of nuclear energy as an innovative and cutting edge technologies in the sector, especially for the next generation. Through different activities like webinars, workshops, panel discussion, and training courses, Winnie will boost the role of nuclear innovation and technology for the future of the energy sector, promote public understanding, and raise the sector's profile. The group has around 21 group members representing different regions of the world, and its events are announced on social media and by email, and they are open to everyone. All the recordings and past events are available on the Win Global YouTube channel. So now is the time to introduce Win for Peace. Please, Anima, over to you. Thank you.
Hello, everybody. Good morning, good afternoon, good evening. And I know for some people, some of you here, it's good night. So thank you for being here, no matter the time zone in which you are. It's such a pleasure to be here today representing Women in Nuclear for Peace. And we are the Safeguards and Non-Proliferation arm of WIN Global. When we talk about nuclear science, the conversation often centers on reactors, power generation, or advanced technology. But safeguards and non-proliferation remind us of something deeper. Nuclear science is ultimately about trust, responsibility, and peace. Safeguards exist to ensure that nuclear materials and technology are used only for peaceful purposes. Safeguards sits at the intersection of science, policy, and international cooperation, where technical expertise must be matched with integrity, transparency, and diplomacy. It's not just technical work, it is peace work, and it's very important work. And for a long time, women have had a critical role to play here. Diverse perspectives from women from all backgrounds strengthen safeguard systems. We improve decision making and we build confidence. Personally, I believe that my journey in nuclear safeguards has shown me that peace is not passive. It is built daily through rigorous science, ethical leadership, and collaboration across borders. No matter where you are, you need peace. And so when women are included and empowered in these safe spaces, safeguards become stronger and more resilient. So if you're interested in peace, if you're interested in technology, pushing the world towards the frontiers of peace, disarmament, come join us. Send an email, go on LinkedIn, you find us, you are easy to find. And if you can't find us, just contact anybody in Win Global and they'll show you the way. Thank you.
Thank you so much for those wonderful words. Seriously, those are very powerful and inspireful. Thank you,
Thank
Jan.
you.
So now, let's start today's session. How we will explore how robotics, drones, and digital tools are transforming the nuclear sector, enhancing safety, improving efficiency, and enabling innovative solutions across operations. The commissioning and radioactive waste management are part of the topics of today, and we are honored to be joined by distinguished experts from Electric Power Research Institute, EPRI, Canadian Nuclear Laboratories, and the OECD Nuclear Energy Agency, who will share insights from real world applications, current projects, and international collaboration. So, this webinar is part of our broader mission to foster knowledge exchange, highlight innovation practices, and empower professionals at all career stages, from students and early career experts to operators, regulators, and policymakers. Thank you for being part of this conversation today. So let's begin. And we will now move into the core of today's session, where our speakers will share their professional visions and hands on experiences with robotics and emerging technologies in the nuclear sector. These perspectives will highlight how innovation is being applied across operations, decommissioning, and radioactive waste management. So, with that, I'm pleased now to introduce our moderator, Yanima Pareapia, who will guide us through our speakers' professional visions and experiences in robotics and emerging technologies shaping the nuclear sector. So, yeah, Anima Opareapia is a PhD student in nuclear engineering at Pennsylvania State University with a strong research focus on nuclear fuel, safeguards, and non-proliferation. She previously served as an assistant research officer in nuclear materials accounting at Ghana's Nuclear Regulatory Authority and holds advanced degrees from Kimawe Nkrumah University of Science and Technology, Beijing University of Chemical Technology, and the IAEA PGEC program in radiation protection. In 2023, Schlumberger Faculty for the Future Fellow and President of Pennsylvania State, Penn State. Yeah, is deeply committed to equity, education, and nuclear non-proliferation. She actively mentors emerging women in STEM and leads community outreach efforts to promote nuclear literacy among underrepresented youth. Her work bridges technology and technical innovation with advocacy, aiming to shape a more inclusive and globally connected nuclear future. Yao also currently serves as the president of Penn State, as well as the networking chair of Penn State's chapter of the Institute of Nuclear Materials Management. So it's a pleasure to have you today, yeah, and thank you for sharing all your broad experience with us.
It's
Now, over to you, please.
Thank you so much, Florencia. It's a pleasure to be here to moderate and hear all that our professional experts have to share with us. So first on the list, I'm going to talk about Darcy. The name Darcy shouldn't be new to you if you've read Pride and Prejudice, and I'm a classics fan, so I like the name Darcy. So Darcy Campbell is our first speaker for today. She is a senior principal team lead at the Electric Power Research Institute, EPRI, where she currently leads and oversees research projects related to radiation safety, low and intermediate level waste management, and decommissioning. Prior to joining EPRI, Darcy was the Director of Radiation Protection for the Los Alamos Legacy Cleanup Project, where she was responsible for the overall programmatic direction for activities in support of decommissioning and waste management. Darcy has over 10 years of commercial nuclear power experience. That's impressive, Darcy. Primarily as the subject matter expert for waste characterization and radioactive material shipping at Duke's Energy Catawba Nuclear Station. Darcy holds a Master's of Science degree in Health Physics from Georgetown University. She received her health physicist certification from the American Board of Health Physics in 2017. Darcy, I'm excited to hear from you and what you have to tell us, what you have to teach us. So please take it away.
All right, I'm going to share my screen. Hopefully it goes well. Uh, are you seeing what you need to see, or do I need to swap displays?
No, we are seeing what we need to see.
Okay, excellent. Thank you very much, Ya, for that wonderful introduction. And I really appreciate the opportunity to speak with all of you today about the work that the Electric Power Research Institute is doing to modernize radiation protection. For those that aren't familiar with EPRI for short, we're a global nonprofit organization, and our mission is really quite simple. We want everyone to have access to safe, reliable, clean, affordable energy. And the way that EPRI is working to make that possible is we perform research, we innovate, and we collaborate with a global network of peers, such as you all, who are scientists and experts in your field. Because of our nonprofit status, we must maintain independence to ensure that all of our work remains unbiased. So when we talk about technologies, there are so many vendors around the world that are working to get these technologies out on the market. And while EPRI collaborates with them, we're very clear that whatever the findings of our demonstrations show, that's what we publish. So if the technologies are good, we're going to say the benefits. If we find obstacles for implementation, we're going to say those too. So all of our research is unbiased to deliver value to our members. EPRI's research spans across all types of energy, but I'm here today on behalf of the nuclear sector. The way EPRI works is that utility companies join as members in order to get access to the results of our research. EPRI's membership in the nuclear sector makes up about 80% of the reactors around the world. So if you work at a nuclear power plant, there's a pretty good chance that your company is an EPRI member in some capacity. And
Mm.
so I'm based in the US, and EPRI's largest offices are in the US, but we do also have locations in South America, Europe, the Middle East, Africa, and Asia. So we truly are a worldwide organization and take different countries' perspectives into consideration whenever we do research.
Darcy, sorry for interrupting you. Maybe can you just change to presentation mode because
Oh,
we see.
oh, okay. I'm sorry. I thought you were
No,
saying
no,
what?
no, no,
Let's
no, no, no,
see.
no worries.
There. Better?
Uh, yes.
Yes.
Please
Okay.
continue. I'm sorry. I apologize for interrupting you.
Oh, no problem. Thank you for interrupting. Okay, so the projects that I'm going to talk about today were funded by EPRI's Chemistry and Radiation Safety Program within that nuclear sector. And so while the technologies that we're going to discuss can be, I mean, and really are being applied across all disciplines, across multiple industries, I'm going to be specifically talking about the radiological benefits that can be realized from these technologies. So, specifically, how can we reduce the dose and risk to radiation workers? How can we leverage these different technologies so workers enter high radiation areas much less, or maybe in some cases, not at all? So, being nuclear professionals, we always have to look at safety first. However, there are also opportunities to improve the accuracy of radiological monitoring, to improve efficiency, and educate workers by using all of these different technologies. So, counting 2020, now that we're into 2026, there has been an 8 year long effort to evaluate and demonstrate all of the different technologies that have been coming available on the market to our members. So, back in the 2019 timeframe, when drones became very popular and were the hot topic item, we started to look at how drones could be used both inside and outside nuclear power plants for radiation monitoring. We also started with some of the more basic remote monitoring technologies, including remote control of locks in nuclear power plants. Then we moved into something called indoor positioning systems, which would allow sites to locate and monitor workers as they transverse through nuclear power plants. So workers could be accounted for if there was an emergency, and this information could also be relayed for work planning. So it would be able to track how long a worker was in a particular part of the plant performing a job. We've looked extensively at emergency preparedness. And we've also done quite a bit of work with robotics, which I think Daniel, who unfortunately couldn't be here today, was going to speak about. So looking at robotics for surveying radiological contamination, but then also kind of an overview of all of the different radiation protection tasks that that robotics could be used for. If you happen to not be an EPRI member, I did note which of these projects are publicly available. So if you go to our website, epri.com, and type in a keyword such as robotics or drone, all of our research results will show up, and some of those are publicly available. So please feel free to search for some of those if they're of interest, and I'm always happy to help. Um, get access to those results. With the time that we have today, though, I'm going to provide a little bit more of an overview of two of the most recent projects we've undertaken related to digital twin and optimized dosimetry. What I found is sort of like with AI, sometimes we'll use the term digital twin as like a blanket term, and it means many different things to many different people. So I'll specifically define what digital twin means in this project. It's essentially taking data of some sort. So in this case, individual radiation measurements and using an algorithm to create a gradient and to guess the radiation data, guess, I shouldn't say guess, estimate the radiation data between the points in order to create this color gradient, which then gives workers a visualization of radiation in the field. So, one of the first reasons that this project came up was organizations were looking at ways to increase safety while also maintaining excellent efficiency and performance. And many existing nuclear power plants have a lot of different ways to collect radiation data. So, whether it be technicians who go out into the field and perform surveys, whether it's fixed equipment, radiation detectors, etc., there's a lot of data, but there's only one, these only count as one individual point. What, as I said, what these digital twin technologies can do is interpolate the data between these points. So then you have a whole picture of the radiation in the field. Since this project started in 2020, and so over the past years, 6 years, we've observed significant improvements and advances in the digital twin technology industry and field. This is an example of a digital twin that was created at a nuclear power plant. And so many nuclear power plants have 3D models of rooms used by your design engineering group or for any other purposes. And so those 3D drawings can be, or 3D models can be uploaded into the digital twin technology along with radiation detection measurements in order to create this this display. Potential applications that are either currently being used or are a target for implementation in the near future are things like work planning. For those that don't have a background in radiation protection, nuclear engineering, etc., if it's their first time in a nuclear power plant, sometimes it's really hard to visualize what environment you're going into. So when they're in an area that's free of radiation, free of contamination, they can see a model of where they're going, as well as the areas of higher radiation and higher risk. Since we can't see, smell, hear radiation, this is incredibly helpful, especially for newer professionals to understand the layout of rooms. Similarly, for training and pre-job briefs, this will be an excellent tool to further educate workers. Digital twin tools allow engineers and health physicists to add shielding. to see what would the impact be if shielding was added. Like, let's say if a pipe had radiation exposure, if you added shielding over it, what would the impact be? Similarly, on the same line of visualization, for emergency planning exercises, so much has to be simulated that these tools could provide a little bit more realism and information to provide those who are practicing and training in emergency response drills. And also live continuous monitoring, trending, and alerts. Many plants, especially new nuclear plants, are looking at ways to transmit data in a very live, real-time fashion. So this, like, let's say this model on the screen could be displayed in radiation protection offices and be continuously updated with the radiation detection measurements that are being fed back from the field. This would allow radiation protection technicians and those that control that work to have the best information and optimize resources to ensure that if some sort of anomaly happens, they're aware of it immediately and can go out into the field. All of this also, which will lead me to the next project, if we have this live data, a lot of it can then be contributed to worker dose calculations, which once again feeds back into that work planning. I did want to make sure to call out my colleague Borja Bravo. He has since taken the lead for many of our RP modernization projects and has done a really great job working with nuclear power plants to demonstrate these technologies. So I'm happy to answer questions, but if you should need any specific information, Borja is available as well. So I mentioned on the previous slide that these digital twins could be, and these calculations could be used to determine worker dose. So for those who may not be as familiar, nuclear power plants, really any facility where a worker could get dose, is required to monitor worker exposures to make sure that occupational dose limits are not exceeded. That's a global truth that every facility around the world has to do. In nuclear power plants in particular, workers typically have to wear two types of dosimetry. A passive dosimeter, which is usually the dosimeter of legal record, and then electronic personal dosimeters. We polled our EPRI members to identify the tasks within radiation protection in a nuclear power plant that are the most resource intensive. And one of the ones that was identified was dosimetry program tasks, primarily because both dosimeters that have to be worn need to be calibrated, processed, tracked. There's a lot of effort that needs to be done. We saw that the medical community uses tools like digital twin and worker positioning systems, like I mentioned previously, that are able to calculate worker dose in certain settings. And so if you imagine a medical procedure in a hospital is quite different from a nuclear power plant. In a hospital, it's a smaller room, there's less people, there's less movement. The source of radiation stays in one spot, where the nuclear power plant is opposite of all of that. So one of the first things we did was to develop a feasibility study to see if we could leverage that digital twin technology that I just mentioned, as well as an indoor positioning system in order to calculate worker exposure. So this is an example of what this looks like, very similar to the digital twin. And this was the work area that was where we did the demonstration. This was a spent fuel cask, so they were working on welding it in place. So this is modeled, and a digital twin is laid over so you can see the dose rate map on a plane. However, these individual points are where the worker dose is monitored, read and recorded. So then it becomes a data point within the calculation in the software. So it's that taking that digital twin and adding a point kernel algorithm to it in order to calculate the dose. So we do have this video. I'll see if it plays of what this. So this was a real time um, what this looked like for the work evolution. So these are the workers coming in, moving about the spent fuel cask as they performed work. Right now, it just looks like they're doing a whole lot of talking, but while they were talking, they picked up dose. And so each little point you're seeing is where their dose was monitored throughout the evolution. So not only will this be able to calculate the individual worker dose, but the next year when spent fuel cask work is being performed, this can be observed and looked at to create more accurate dose estimates of the work being performed. There are, of course, this technology continues to be developed. There are many benefits and many potential applications, but also some things that need to continue to be worked out. For example, workers can very easily shield one another if they're working in close proximity. So, which worker is receiving which dose, or even if the worker can be identified by the monitoring system, still needs a little bit of work. However, this has been implemented at the site where the demonstration was performed, and they are currently validating the data that's received. So workers are still wearing their two forms of dosimetry while also getting their dose calculated. So the ultimate goal is after we have enough demonstration results to achieve statistical confidence, we can show the similarity and the accuracy of the calculation mechanism when compared to the normal dosimetry. I believe that is my last slide. So thank you very much for the time. I think we're going to do Q&A at the end. So I look forward to hearing your questions, and please don't hesitate to reach out should you need any additional information from me.
Thank you so much, Darcy. I enjoyed watching the video of
Yes.
seeing people being contaminated in real time. In real time. Thank you. I have just one question for you before I leave it to the audience to also have ask their questions. So, first question is, what major advancements in robotics does EPRI see as the most transformative or radiological operations in the next 3 to 5 years?
So I think with robotics, one of the largest, I think that's being implemented right now is a lot in the decommissioning space. So things where workers would previously have to enter an area to do demolition or something like that. Now they don't have to. So that's, I think, overall the industry. From radiation protection in particular, having the robot be the additional resource that can always be in the field, roving around with radiation
Mhm.
detectors to monitor dose rates in the field is a wonderful resource because no human is getting dose from being
True,
out in the field for 8 straight hours. So I think
true.
that improves monitoring capabilities, and that
Mhm.
also helps nuclear power plant personnel determine which areas are higher risk or need higher attention for actual people to go enter and do work.
True, I agree. Thank you so much for such a thorough answer.
Thank you.
If anybody in the audience wants to ask a question, we are open to hearing them. If not, they can just put their questions in the Q&A session, and then we can continue to hear from Alexia.
All right. Thank you very
Al-
much.
Thank you so much, Darcy. Alexia, are you ready to give us your magic?
Yes, no pressure, but I'm here. Yes.
Okay, so everybody, I'm gonna introduce Alexia now. Oh, wait till you see her list of accomplishments. Alexia is a project lead in the OECD Nuclear Energy Agency's Division of Radioactive Waste Management and Decommissioning. She leads the expert group on robotics, emerging and advanced techniques in the nuclear back-end, e.g. REAT, as well as a thermochemical database project. Her background includes research on molten salt corrosion for Generation 4 reactors, nuclear forensics, and environmental chemistry. She holds a master's degree in chemistry from Sorbonne University, Paris. That's nice. So, everybody, if you are ready, let's hear from Alexia. Thank you so much, Alexia. Please go on.
Thank you for the very kind introduction. Let me share my slides and Mhm. I would appreciate if you will confirm that you're seeing the right window, or are you
No,
also seeing the no? So I'm
we
swapping.
are, we are saying yes.
The one is right?
Perfect, yes.
Okay, perfect. So thank you for introducing me. As was said, I'm Alexia. I work in the RWMD. And thank you for giving us the chance to present some of our work, specifically on robotics and emerging technologies. So a little bit like Darcy in her presentation, I'm due to present what the NEA is. The NEA is an intergovernmental agency. We work to represent 34 member countries, and our membership represents about 80% of the world's installed nuclear power. And what do we do? Basically, we are, I would say, quite similar in the mission to EPRI. We are trying to assist our member countries through international cooperation to help them develop the safe, environmentally sound, and economically viable nuclear energy for peaceful purposes. And the idea is to get the common understanding and then provide further input to governments and ministries, more often than not in collaboration with the OECD. Before I get started on the robotics part, I just wanted to highlight one of our latest publications. You might recognize the name. The report you see here on the left was prepared and led by Emma Wong, who is quite active, I think, in WIN. And the report is summarizing some of the latest initiatives in nuclear innovation and newly emerging disruptive technologies. So I cannot read all the reports out loud, of course, but some of the keywords you might be interested in are, for instance, distributed ledger technologies, enhanced materials and advanced manufacturing, automation, etc. And the idea behind this report was that a lot of organizations provided their individual chapter to present what they're currently doing. So if you're looking at the bottom right, you will see the QR code where you can access the report freely. In my case, as we stated, I work in the back-end side of nuclear energy, so we focus more on radioactive waste management and decommissioning. And when I was asked the question, I thought, where does robotics and digitalization help? So we've had a wide range of applications that were discussed within our different expert groups during our big meetings. And I've listed here a few. When it comes to radioactive waste management, quite obviously, I would say everything remote, everything you can control remotely will lead to dose reduction, as was highlighted in the previous presentation. But using advanced technologies can also help you reduce volumes of secondary waste. I have in mind one of our latest presentations in our group of a technology to scan odd-shaped pieces and determine the level of radiation and then optimize the volume of water needed and the pathway needed to decontaminate the object. You can also improve operation with the help of automation and AI. I will show in further slides, but I can already hint at, for instance, automatic way to sort through waste, again, to differentiate between the different levels of radiation. When it comes to decommissioning, it's quite similar, but also quite different. So you've seen the videos of the mapping. We have the same conclusions here at the NEA that you can employ drones for characterization, not only within a plant, but also in the environment. That can help you build digital twins and other types of models that then help you with different types of configuration that might facilitate how you plan your decommissioning, that might help you understand better what are the bottlenecks and what might be the cost. Another aspect of it is everything related to archiving. If you are familiar with the nuclear backend, you will know that when it comes to long-term radioactive waste management or even decommissioning, all of these activities are in the tail end of the nuclear energy cycle. And therefore, you will probably end up with a big stack of documents that were written by different people from different organizations, with different standards applied, and therefore you might be able to get a little help from AI technologies to sort through this pile of document and run analysis, which also might help you in the long run with your decommissioning plan or how to store your data about your waste. So now in the next few slides, I will briefly give a gist of one of the first reports we published in the robotics group. Similarly, you will see here at the bottom right the QR code. This was the first report of the group where they tried to take a snapshot of the status, barriers, and cost benefits to robotics. So when they started with the status, they actually discussed what was the drive for robotics development. And it turns out if you were doing spent fuel management, due to safety reasons, you were very much inclined to find ways to develop remote technologies. So at the beginning, it very much started with what we call master-slave manipulators that you will see, for instance, at the top right corner. At the beginning, it was mostly safety driven. It was not so much about efficiency or economic viability, which was a little bit in contrast with the rest of the manufacturing industry, for instance, the way we do cars. And so for quite some time, the remote handling was mostly done with the expert human in teleoperation that required a fair amount of training, dexterity, some big muscles in your arms. So it was quite difficult. And in particular, it was also difficult to get a sense to have force-sensitive haptic. So things were a bit slow for, I would say, maybe not a couple of decades, but kind of. But then things started evolving, and eventually we're now, as you will see at the bottom right corner, moving towards more autonomous system. Autonomous system that can maybe plan paths, that can identify objects, that can maybe pick the best tool. And that is a spectrum of autonomous. You can have a human or not in the loop, which is all quite exciting. However, all of the experts in our group have recognized that these technological advancements lead to new challenges. You might have to wonder how to do your benchmarking, how to certify your safety, and how to retrain or train your workforce, because it's a very different profile from someone doing direct teleoperation to someone supervising a piece of software that might be rewritten. In that first report, we also had quite optimistic case studies. One of them, for instance, was from Belgium, where they showed how by taking more than 38,000 tons of soil, they were able to sort through it within less than 3 years, about 3 years, by using a automated belt. And thanks to this, in the end, you will see here the figures on the screen. They went from 38,000 tons of soil to mostly 36,000 tons of unconditionally released waste, about 2,000 tons of waste that needs to be sent to landfill, and then only 1.3 tons of waste that needed to be handled by the Radioactive Waste Management Organization in Belgium. So that was one of those very clear-cut case where it was beneficial to implement automation and to a certain degree robotics. Another example brought forward by one of our members was in Slovakia, where they have been using robotic arms to segment steam generators. And in that case, I can still remember the faces of awe of the rest of the experts when the figures were showed on the table, that it took, I think, at maximum 60 days for fragmentation of one steam generator, and then the system could be reused to fragment other steam generators. And that led to very obvious time-saving benefits as well as cost effectiveness. So pretty encouraging signs here. Because they were doing so well, the group decided to keep going forward and to build on this first report. And so then they continued their work looking at benchmarking, looking at further cost-benefit analysis, but also asking the question on how to perform regulation. Oh, I've seen... Oh, sorry, it's the chat. It's not, there's no problem. So similarly to the previous slides, you will find here the QR code. I will give you a little bit of a gist of what's in there as well, but please feel free to download the report or ask me questions later. For the that they observed from the first years of working together, that there was always some reluctance and some fear to invest in a new technology for which you didn't have much data. But then the question was, how do you know that this data is good? And therefore they started discussing, okay, us as experts, how do we actually assess when a robotic system is good or not good? Can we really rely only on commercial data? Can you really rely on the expert opinion of someone? And so therefore they started drafting a benchmarking categorization, but also benchmarking methodology. For this, they didn't start from scratch. They had some previous NE experience in the way we're conducting peer reviews. We have a couple of peer reviews for the backend, but also peer reviews on how to assess new SMR technologies, for instance. So they had something to start with. And they went as far as handing over this methodology to a complete external expert and ask him to go through the methodology to give some feedback. And the results were quite encouraging. So I think in the next year, they'll hand over the same package to a few other experts to see where this is going. And the idea on the long term is to have a core data set of peer review data, but also have this community built so that there are point of contacts between, suppliers, but also end users, maybe let's say academia, researchers, or even why not regulators. Speaking of regulators, as I said, the group also discussed what was the issue with, implementing a new robotic solution or a new innovative solution? And while everyone was worried about regulation, a few members said, you know what, let's dig deeper. What's the actual problem with it? think actually 11 or 12 case studies how technology is being developed and how they're trying to how was the interaction with the regulatory bodies or with the different standards available. And so in it, you will have different countries represented, different perspectives, and different types of technology as well. So I encourage you to have a look if you're curious. Another initiative taken by the expert group on robotic was to start a series of webinars. They started at the end of 2024. They started out strong. They had focus episodes on the implementation of robotics at Fukushima and Sellafield. Then they moved on to other types of sites, deep geological repositories or underground research labs. Then they did a little bit of a detour talking about how to import non-nuclear technology. And the reason is because in many cases, nuclear robotics is somewhat of a niche, but you have a whole other industry full of nuclear experts that are developing very advanced solutions and that are sometimes curious or surprised that you cannot just drop a robot somewhere on a nuclear site with the different nuclear constraints. Then the last episode was one dedicated to decontamination technologies. And coming up next, we will have a radiation tolerant components for robotics episode. You will see here there are a couple of links. That is because we do not record the webinars, but we do make the presentations available when possible. I'm happy to say the group was really quite active because beyond the reports and the webinars, they have also organized a workshop on the role of innovation in the nuclear backend. This was held last April in Cumbria, where Sellafield Limited was our co-host. In this event, we were about 150 experts. It was mostly senior people, but we were also quite excited to see more early career professionals in research, but also in the regulatory side. It was a mix of technical presentation, discussions on implementation challenges, but also site visits with a few demos from our exhibitors. And so some of the topics we discussed were, use cases, or not use cases, but case studies, yes, from different member countries. We also, as I said, discussed implementation challenges. We had a few presentations on the latest technical advances on a variety of topics, from characterization to dismantling. We also discussed a lot of quote unquote neighboring topics, not just the robots or latest techniques, but what happens when you need to integrate together robotics and human systems. The implication when it comes to digitalization and cybersecurity, or what are the safety considerations when you increase the autonomy of your different systems. Just to say that the presentations are all available online if you're curious. There's also the detailed program. And we are wrapping up the proceedings, which I hope will be published in a handful of weeks, if you want to know what we discussed in more detail. So I'm getting to the end of it. What were the main lessons learned from all of these activities? I won't read through all of them, but basically we all agreed in the group that there were significant gains from using robotics and AI for those nuclear backend sites and applications. But we still noticed that there was a race to the second place that was in part due to the lack of data and the lack of feedback between the users and the suppliers and tests. The business cases were not always obvious, especially because in the back end, you don't want to put more money in. You mostly want to use as little money as possible to do as best as you can. Yes, that was what I wanted to say here. And in addition, the experts also all noticed that your technology is never going to be a silver bullet. Just dropping it is not going to do much. If you want success, you need to have a plan for its integration. That means you need to think about maintenance, you need to think about training, you need to think about involving the different experts in, let's say, cybersecurity. This is one of the reasons why having clear roadmaps really help. You can identify who are the stakeholders and when they intervene during the life cycle and the implementation. In addition, there was a lot of discussion on regulatory proactivity. We saw that when the regulatory body and the staff were taking initiative to keep an eye on innovation, it led to clear benefits to the entire ecosystem. But on the other hand, also when the supplier or the licensee were trying to engage with the regulator at the early stages, it also helped understanding better the data that might be needed or the guarantees that you needed to show. Another thing that was quite interesting was that all of the presentations and all of the implementation challenges that were highlighted showed that having more digitalization, having more advanced applications require that you have a very well-defined data governance policy and that you let the cybersecurity mindset seep through the rest of your organization, not just the cybersecurity team. And other benefits were that having advanced technologies, sometimes in areas where you're decommissioning your reactors, can really incentivize keeping up the local economy and have more career, be more exciting for the younger generation. And finally, we also saw that, well, sometimes people think the backend is boring because it might be, I don't know, a bit longer in the time scale. But at the end of the day, this is also where you can do a lot of testing for your technologies, and it can be a real driver force for advanced technologies. And just before I conclude, I promise this is the end. I just want to quickly advertise our new group then. So the robotics group I mentioned has just been rebranded. It's the E-grade, to put it this way. And we're basically doing the same as we were doing before, but just expanding the scope a little bit more so that we can look in deeper detail at drones and how to handle continuously collected data. That is the end for me. If you have any question, don't hesitate to reach out. If I don't have the answer, I will for sure connect you to the right person.
Thank you so much, Alexia, for your presentation. We have two questions actually from Ezekiel Ama Ashai. I don't know whether he can read it out himself, but I'm gonna try and read it if he can't read it out himself. So, my name is Ezekiel Ama Ashai from Accra, Ghana. Hey, shout out to you. I work for WEM Africa, and I am with the Nuclear Security Department. Ghana is preparing for the construction of its first nuclear power plant. As we discuss emerging nuclear technologies, particularly robotics and AI. Oh, his hand is raised. Please go ahead. Ezekiel, please ask your question.
I think you need to give him speaking rights.
Yes. Hello.
Yeah, please. You can hear you.
Yes. Thank you very much for the opportunity. As you said, my name is Ezekiel Amashai, and I'm with WEM Africa. So I want to continue from where you left off. As we speak, Ghana is preparing for its first nuclear power plant, and I can see we are discussing emerging nuclear technologies in the area of robotics and AI. So I want to know how radiation-hardened robotic systems can be integrated into the construction phase of Ghana's nuclear power plant to conduct high-dose inspection. That's the first question. And then secondly, I also want to know how we can integrate and then make drones do autonomous inspection controlled by AI to monitor concrete integrity and then radiation safety of workers at the facility.
Ezekiel,
Yes,
are your questions for Darcy or Alexia?
my question is for Alessia Mercia. And
Yes.
there's this last one I want to ask. Please, can I go ahead with it?
Yes.
Yes, Madam Alessia, in one of her slides, she spoke about, where robotics and digitization can help, especially in the, automation processes. And I want to know, do we have some challenges associated with the automation that we should worry about? What are some of the challenges associated with the automation, the using robots for this kind of processes? What are some of the challenges associated with them that we should worry about as far as our safety is concerned in terms of radiation? Thank you.
Thank you for this question. So to talk about your first question, where you asked about the red hard components, I will say in our case, within the scope of our group, we're not so much thinking about how you build a reactor. I will say, I think Nicholas, who is one of my experts, is part of this call. But when you build a reactor at the beginning, it's mostly civil engineering issues that you might have, and you don't need so much red hard components. In our case, what we have discussed was mostly in the case of, let's say, complex sites. So if you talk about Chernobyl, if you talk about Fukushima, if you talk about sites where you had spent fuel pools and you're not sure if something has leaked into the pool, this is when we would talk about those components, not so much as the building a reactor stage. For the second question that you asked, if I remember well, you said something about the issues with automation. And for this, and robotics, but mostly automation. For this, the first thing that comes to my mind is a case study we had from Sweden, where they were discussing their waste management, their underground waste management repository, where the expert that came to present said, actually, if you put only robots, autonomous vehicles and remote arms, everything is going well. If you only put humans, everything is going quite well. The problem is when you start putting a man on a car that needs to interact with the autonomous vehicle, and then you're never sure how automatic behavior, and that creates actually more uncertainty. So this is one of the issues that we have discussed in the scope of our group. For us, we have mostly seen benefits so far that, for instance, when you do, I don't know, measurement of drums and you check for the dose on the outside, having automation was always like positive benefit. You have more consistent data. It's always taken the same way. You're always at the same distance from the drum. So we did not so much discuss issues that came with automation. Now, if you are hinting at things that are more like black boxes, like, I don't know what people say, AI, then we have much more issues when it comes to certifying the safety. And where you put responsibility and liability if there's a mistake. But again, for this, we could talk for hours. I invite you to look at the case studies that we have, and if there was any specific question, I'm happy to answer by email or connect you with the person behind it.
Can I
I hope that
also
answered. Oh yeah, sorry, Darcy,
Yeah,
please go ahead.
if I could supplement as well. So Ezekiel, one of the things that we found was not so much the radiation hardening issue. I think Los Alamos National Lab did a study that showed that robotics are able to withstand, significantly high dose rates, greater than that which you would see during normal operations. However, some parameters that from our research we found really challenge the robotics are things as simple as humidity. So, if one of the great benefits of robotics is being able to send a robot within the reactor building at operation instead of humans. However, we saw at least three instances where the humidity within the reactor building during operation caused the robot to essentially stop working in place, and then someone would have to go in and retrieve it. So I think to Alexia's point, there's so many parameters. We first think about radiation hardening, but then there's so many other parameters that also need to be considered when that are just a normal part of operations. And then from the automation perspective, I think one of the best things that you could do as a nuclear newcomer that lends itself to better automation is having great records from the beginning, in a good, I think Alexia said this as well, in an easy to read format, so you can feed it into the machine easily from the beginning. Because for so many of us that worked at nuclear power plants that had to use data from 40 years ago, it's just scribble and you can't see anything. So I think that's the best thing that you could start on as well, is getting things in a very easy to read, easy to record format.
Thank you for such a thorough answer. We have one more question from Ayman Priya from Westinghouse. So, Florencia, if you can allow Ayman to ask his question.
Sure. Let me just check in the list of participants. And now it's Amen is able to talk.
Mm-hmm.
All right. Hello, can you hear me?
Yes, we hear you. Please go ahead. Thanks.
So, good morning, good afternoon. Thank you, Alexia, and all the team for this great webinar. My question is very simple and very straightforward. We're very interested about the work you're doing. I think it's the robotic in nuclear, as you are raising that in the group name, it's emerging technology, and when it's an emerging technology, I think gathering efforts, it's the key word. So we would like to collaborate, and we would like to be part of the expert group that you guys are part of. My question is, how can we be part of that group?
Thank you. That's a very good question, and I'm certainly glad that you asked it. The answer, unfortunately, is it depends. As we're an intergovernmental agency, all of our delegates, all of our members have been nominated by their national delegations. So I do not know which country you are representing now, but it would mean that if it's a member country of the NEA, you would need to reach out to your national delegation. You can send me an email. Based on your delegation, you could be joining the group. However, we are, of course, very understanding that this is a lot of constraints. So regularly, we try to have more open workshops where we might invite more stakeholders that are not usually nominated by their delegation. It is not official yet, but we have plans to have a workshop later this year. So again, if you're interested, let's keep in touch, and I will give you information as soon as it comes out. And every now and then, we might also involve people when it comes to case studies. So again, if I know who is the person, then I might reach out if we're collecting case studies. And then finally, everything regarding webinars. The same, we often invite, just like here, we often invite experts who might want to contribute or who might want to take part in the Q&A so that expertise can flow around.
All right,
I
thank
hope
you.
it's many different options basically.
Yeah, I appreciate your detailed answer. I mean, Westinghouse, it's a US company, so and we have teams everywhere. So we will talk about that by emails. But once again, really, it's
Yes.
very nice insights, and wish and thank you on the behalf of the whole community. Thank you.
Thank you.
Thank you
Just
so much.
a quick comment to Alexia and Darcy. If you can drop your email contacts that maybe people can reach out to you on the chat. And as you said, Alexia, if you can direct to the right people in the agency to follow the protocols, so we will appreciate that. Thank you. Sorry, Jen. Please continue.
I've had questions, but they've all been answered whilst you were giving your presentation. So I'm so thankful to you all.
We have a last comment from Carla.
Okay.
She's our co-leader. Carla, would you like to open your mic to give your overviews?
Hi, Florenza. Thank you. Yes, it's just a comment for Alexia. Congratulations, Alexia. Really, your presentation and the approach you presented, because we've been saying for a long time that regulation is a bottleneck, but really no moving innovation forward in the nuclear sector or any sector without approach and go deep in each real problem. So we need to advance, and we cannot give this excuse anymore. We need to approach the specific problems and go forward to this. I wish you all the success, and thank you very much for your presentation.
Thank you very much. I just would like to highlight that I'm only here to present the work of the expert group. So it's actually the experts that cannot join, if 30 of them today, but it's really their work. And indeed, it was a couple of them really wanting to challenge what's behind this regulation is the problem. And we're very thankful to have had this work done.
Yes, thank you.
Great. Jen, any last comments or questions we see on the chat? I think we are done with the comments, right? Yeah.
I believe so.
Well, we are approaching end of our webinar, and I want to thank all the organizers, also part of the team, all the supporters, everyone who make today's session possible, and also to Jeff for moderating tremendously today. And sincerely thank you to all the speakers, participants for an engaging and insightful discussion. We have explored how robotics, drones, and emerging digital technologies are being applied across nuclear operations, decommissioning, and radioactive waste management, demonstrating tangible advances in safety, efficiency, and innovation. So, the perspective shared by our distinguished panelists proves its importance in the practical deployment, international collaboration, and continuous learning as the nuclear sector evolves. So, on behalf of Women in Nuclear Innovation and Win for Peace, we thank you for being part of this exchange and for your commitment to advancing innovation responsibly in the nuclear field. Please stay connected with Winnie and Win for Peace for upcoming sessions and initiatives, and we look forward to seeing you at our next events. Thank you again, and have a wonderful rest of your day. Mrs. Eva, would you like to say some few words before we close today's session? We will appreciate your comments.
Well, thank you very much, Florencia. First of all, a big thank you to Florencia because she's the mastermind behind these webinars, and she's also always there, always organizing things, and always on the spot for everything. So first of all, a huge thank you to you, Florencia. And last not least, of course, to our two wonderful speakers. I think all these sessions have been very enlightening and a real learning experience for our audience. So thank you very much for that. And also, last not least, Anima, a big thank you to you. You did a wonderful moderation. I'm really proud of you. She's one of the members of Win for Peace and of which I am the leader. So another success story. Thank you very much. And I look forward to meeting you at any of our next webinars and also our two speakers. Maybe you can contribute to our future webinars as well. Thank you, our audience, for connecting today. And I hope you found this as interesting as myself. I wish you all a nice day, night, whatever is ahead of you. Thank you.
All right. Bye.
Thank you. Bye bye. Thank you
Bye
for
bye.
today.
Bye.